So let's start this out. So we see that we have a project network with activities A, B, and C. And the durations are as shown. So activity A has 3 days of total flow. Activity B has 3 days of total. Activity C has 2 days of total flow. Activity A requires 2 workers. Now we're looking at resources, right? Workers. B requires 4 workers, and C requires 2 workers. So these are part of our question, and this is what we need to apply. So we're going to look at this, and so the only way to solve this problem is identify how many paths there are, the duration of each path, the duration of each path, the critical path, and we're going to calculate the total flow for each of these activities. But let's take a step back, and so let's see what the dummy does. Let's eliminate the dummy. Let's forget about them. They don't exist. So if I get rid of the dummies, right, that means that I have 3 activities that are not connected. That's it. So it's like 3 random activities. It's not a network, and as a result, when I put the dummies back in, they provide the network logic as we explained when we looked at that. So now this is a project where 3 activities have to come together for it to be finished. So let's list all the paths. So we have path A, we have path B, and then we have path C. The durations of each. So A, it's given to us that it's 2 days. B is 5 days, and C is 3 days. So we're going to determine the critical path, which is the longest path through the network. The earliest possible time that we can complete this is in 5 days. Now we're going to calculate the total flow. Well, if the total duration of the project is 5, that's our critical path. 5 minus 2 is equal to 3. 5 minus 5 is equal to 0, but I didn't have to do the math. I really intuitively know that it's a 0 because it's on a critical path. 5 minus 3 is equal to 2 days of total flow. So we completed this fairly quickly, and we're understanding all the principles that we just learned in this entire chapter here related to scheduling. So we're going to answer the 2 questions, and they are: if activities start on day 1, the number of workers needed on day 4 is most nearly, and if activity C is delayed 2 days, it's total flow. I can delay C 2 full days and not affect the project. How many workers are needed on day 4? So once again, the only way to solve this problem is to create a histogram. Okay, that's it. And evaluate the question. So here, what we're going to look at is just that. So on our y-axis, we're putting our workers, right? So these are our workers. And so we need 2 people for A, 4 people for B, and 2 people for C. And so that is what we laid out for this particular problem. And the duration in days are at the bottom. So when we look at this, we see that we have a total of 8 people required on day 1, 8 on day 2. We need 6 on day 3, and we need 4 on day 4 and 5. So what I just drew on the screen here, and I'll move it up and shake it around a little bit, is that is the irregular line. It's not level, right? It's not level at all. It's not level. It's irregular. And in project management, it's very, very difficult to manage highs and lows. You want a steady flow of workers. You can easily manage a steady flow of workers. In this case, you have highs and lows. You want to avoid that. That's the purpose of resource leveling. So now let's take a look at the next. So resource usage. If we delay C, it's 2 days right here. If we delay C 2 days, what happens? Well, this time I only need 6 workers on day 1, 6 on day 2, 6 on day 3, 6 on day 4, 6 on day 5. And so what I just did is I now have a resource leveled project, and that line identifies that, right? That identifies that it's a resource leveled project, and that is the goal of our objective of getting there.